Okay, here we're asked to determine which of the following ordered pairs represents a solution to the equation graphed below. So when you're searching for ordered pair solutions to equations, basically what you're asking is, will that ordered pair appear on the line when the equation is graphed? So you can do this graphically or algebraically, and we're going to do a couple examples of both. So first, graphically. Usually if we're given an equation, we would have to go through the steps of actually graphing it and then determining if the points are on the line. But in this question, we're given the graph, so that saves us a step. So we have the points 2, 0, negative 1, 2, 0, 3, 1, 5, and 2, 2. And all we need to do is determine whether they're on the graph. So let's remember that any point on a coordinate plane is written as an x, y coordinate. So our x is the first number, y is the second. So let's go ahead and start graphing these and just see if they come up on the line. First we'll do negative 2, 0. Negative 2 on the x, 0 on the y is that point there, which does appear to be on the graph. So we'll put a check there. Same with negative 1, 2. We go negative 1 on the x, positive 2 on the y, and we are there. So that one is not on the line. We'll go 0 on the x, 3 on the y, also not on the line. We'll go to 1, 5, 1 on the x, 5 on the y, that is not on the line either. And finally, the point 2 on the x, 2 on the y, which is not going to be on this graph. So the only one that was on the graph, and that's the only one that satisfies the equation, is the point negative 2, 0. Okay, so let's go to the next one here. So this one, we're given the algebraic equation as opposed to a graph of it. Now we could plug in some x and y values and graph the equation on some graph paper and then just see if each point appears on that graph. And that's always an option. But another option is to create an XY chart and see if the x values for each point satisfy the y values. So what that means is, for all the points that we're given here, remember a point is written as an xy value, so we have negative 2, 9, and what we're asking ourselves is if we plug negative 2 as the x into the equation y equals negative 3x plus 2, if we plug that negative 2 in as the x, will we get a 9 for the y value? Okay, so we can try it with all these equations, but let's write down all of our points first here. There we go, so we have negative 2, 9. Then we have negative 1, 3. We have 0, 0, 1, negative 1. Just a little bit longer of a T-chart here. And 2, negative 3. Okay, and we want to know if these points are going to satisfy the above equation. So we have y equals negative 3x plus 2. And let's start plugging in our x values. Now you could plug in y values as well and see if that gets you a given x. You could even plug in the x and y value and see if the two equations simplify to a correct answer. And I guess I can do an example of both of those. But first we'll just try plugging in our x and see if we get that y. So we have y equals negative 3 times x, which we're plugging in a negative 2, plus 2. So negative 3 times negative 2 is going to be positive 6, because a negative times a negative is positive. And then we add 2 to that to get 8. So our equation simplifies to y equals 8, and 9 is not equal to 8, so the first point does not satisfy the equation. Okay, for the next one, we could go down the line and just plug in x on each one of them, and maybe that's the easiest way, but just to show you there are multiple ways to do it, let's try plugging in the y. So So instead of y, we have 3 equals negative 3x plus 2. And we want to get the x isolated, so we're just going to subtract 2 from both sides to get 1 equals negative 3x. And we're going to divide by negative 3 to cancel that out to get x is equal to negative 1/3. And negative 1/3 is not negative 1, so that one does not satisfy the equation either. And finally, let's just try plugging both of them in for the point 0, 0, and see if that simplifies to a true statement. So instead of y, we put 0 equals negative 3 times 0 plus 2. And then negative 3 times 0 is 0 plus 2. Drop everything down. And then 0 does not equal positive 2, so that one is not going to satisfy it either. All right, just for time's sake, let's just go back to plugging in x values only and solve for the y for the last 2 points here. So our x value is 1, so we're going to get y equals negative 3 times 1 plus 2. Negative 3 times 1 is negative 3 plus 2, and then negative 3 plus 2 is negative 1. So that one is our first point to actually satisfy the equation. And our last point down here, we're going to plug in a 2 for the x. Negative 3 times 2 plus 2. And then negative 3 times 2 is negative 6. Plus 2 is going to be negative 4. So we will get y equals negative 4, which is not equal to negative 3. So that one doesn't satisfy it either. So the answer would be 1, negative 1. And there we go. I hope this helps.